So welcome everyone. This is 9.1 on solving equations by taking square roots. And before we solve equations and we get into the examples of solving equations, let's first talk about the properties of radicals. Okay, so in order for us to simplify radicals or to use radicals, we're going to be using these two properties. Okay, the first property is when we have two numbers being multiplied in my radical, I can split this up and say it's square root of A times square root of B. Okay, this becomes useful when we are simplifying radicals, just like the square root of 36. We all know that the square root of 36 is 6, but we can also simplify it by saying that 36 equals 9 times 4, right? And the square root of 9 then, if I split it up, times the square root of 4, where the square root of 9 equals 3, square root of 4 equals 2, so 3 times 2 is 6. Okay? So that's one way of using this property when we're simplifying. We can also simplify using the same type of property when we are dividing. So when we have the square root of A over B, two numbers, we can split up the square root and say it's the square root of A over the square root of B. Okay? So just like this example, square root of negative square root of 0.16 is the same thing as the square root of 16 over 100, okay, in fraction form. We put it in terms of 16 over 100 because when we split it up, square root of 16 divided by the square root of 100, square root of 16 is a perfect square, right? It becomes 4, square root of 100 becomes 10, so 4 divided by 10 is 0.04 or 0.4, okay? And notice that the negative, it just travels with it, okay? So it's actually negative 0.4. All right? So those two properties we need to know, and we're gonna practice them by doing C, D, and E. But just for practice, plus or minus square root of 49, that is, square root of 49 is 7. So that's positive 7 and negative 7. Easy, simple. Same thing with square root of 25, plus or minus. So since it's plus or minus square root of 25, square root of 25 is 5, so positive 5 and negative 5. Okay? All right. Now when we have this type of awkward number, and this extends out to the 3 as well. Okay? Square root of 12, that's not a perfect square. But we can still simplify this by saying 12 equals 4 times 3. So we're looking for the perfect square. Remember, the perfect square is 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So we're trying to look for all of those numbers, right? 6 squared is 36. 7 squared is 49. 8 squared is 64, right? 9 squared is 91, and so on and so forth, right? So if we use one of those properties, square root of plus or minus square root of 4 times 3 is the same thing as plus or minus square root of 4 times square root of 3. So square root of 4 is 2 square root of 3. So this is the simplified version of square root of 12. Okay? example. Square root of 16 over 9. That's the same thing as square root of 16 divided by the square root of 9. Square root of 16 is 4. Square root of 9 is 3. So plus or minus square root of 4 over 3 is the same thing as square root of 16 over 9. Oh, I'm sorry. Plus or minus 4 over 3 is the same thing as plus or minus square root of 16 over 9. Okay. The last example that I have for this batch is plus or minus square root of 0.27. 0.27 is the same thing as 27 over 100. So this would be plus or minus square root of 27 over square root of 100. We know that square root of 100 is 10, right? So my denominator is 10. Square root of 27, that's the same thing as 9 times 3. 27 is. So I can break up my numerator into square root of 9 times square root of 3 divided by 10. Right? So square root of 9 is 3 times square root of 3 over 10. Now, this 3 here is the same thing as this square root of 3 here. Okay? All right? Cool? Questions on A through E? Yeah. Because square root of 12 breaks out to be, the question was, why is the answer 2 plus or minus 2 square root of 3? Because 12 breaks out to be 4 times 3, right? And then when I split it up, it becomes square root of 4 times square root of 3. What is square root of 4 though? 2 times, and then this whole thing here is left as is.
Why 12 2?
Because square root of 4 is 2 without the square root. Yeah. Because square root of 4 equals 2, right? Plus or minus, plus or minus. And the plus or minus is important, and I want to talk about the importance of it later on. Okay? All right. There's another rule that we have to know. It's called rationalizing the denominator. You're going to hear that a lot in terms of this module. Okay, the rule is we cannot have a square root in my denominator. We must get rid of it, right? Or we must move it to the top. So if I have 5 divided by the square root of 6, right? I can't have a square root in my denominator, right? Which this one does, the square root of 6. Now, let me ask you a question. I'm going to be multiplying this by something. Yeah, I'll tell you that much. Okay, but my question to you is, I don't want to change the value of this answer. Okay, the answer must be 5 square root, or 5 divided by the square root of 6. Okay, what do I need to multiply? What number is there out in the world where I multiply by it and the value stays the same? 1. If I multiply anything by 1, the value is the same, right? 5 times 1 equals 5, right? Yeah? Stay the same. 7 times 1 equals 7, stay the same, right? So we're multiplying it by 1. Not just an ordinary 1 though, because that won't change anything, right? It will still look the same way. But what do I need to multiply then? Square root of 6 by to get rid of my square root in my denominator. square root of 6, right? So if I multiply this by the square root of 6, then I know in my denominator it's going to be the square root of 6 times 6, which is square root of 36, right? And in that case, square root of 36 is the 6, correct? But going back to what I multiplied by, right, square root of 6, I can't just multiply square root of 6 in my denominator. I must multiply it by 1, right? That idea of multiplying things by 1. I must multiply this by square root of 6, right? So square root of 6 divided by square root of 6, that's 1. Just looks a little bit funky. So this would just be 5 square root of 6. This would be 5 square root of 6 as well. I can't do anything with it. So this would be my answer when I rationalize the denominator. So this guy here in blue and purple, the box one, is the same value as this, but it just looks different, right? There is no square root in my denominator, okay? So we are just going to be multiplying it by my denominator over my denominator, right? So this one, 2 over square root of 3, we're going to be multiplying it by square root of 3 over square root of 3. Yeah. So we can say that the top, my numerator is going to be 2 square root of 3 over 3 times 3 is square root of 9, which is 3. Okay? All right. So now I multiplied it by 1, so the value stays the same, and my denominator does not have a square root in. Okay? Cool. How about this one? I'm going to be multiplying this by square root of 5, right? So square root of 6 times square root of 5 is what? $30? Yeah. Over 5 times 6 is 35. That's my answer. Cool? Yeah, we just multiply by itself. Okay?
So you're not simplifying for this one?
We just did. We multiplied by it. Or for this one, we cannot. I know 30 goes into 5, right? But one number, the 30 is underneath the square root. The 5 is not. So we cannot simplify. Okay? Yeah. Yes. Yes. If it was the square root of 30 over square root of 5, you can simplify to square root of 6. Okay? All right. Okay. Now we're going to dive into some equations. Okay, now that we've had exposure to the properties that we're going to use. So in this case, my goal here, notice that there is only x squared to beginning with, right? There is no x value. It's a squared. So we're just gonna solve it like a normal equation like you did back in integrated 1, back in algebra 1 or pre-algebra, right? Where we solve equations. Yeah, so in this case, we're gonna add 5 to both sides first. So then that would be 4x squared equals 5 plus 2 is 7. And then I'm gonna divide by 4, divide by 4. So then I have x squared equals 7 over 4. Okay? And now how do I get rid of the squared? Because this is what's next, right? I have to kind of move to the other side. What's the inverse of a squared? Square root. So I got a square root both sides. Okay? So x here, x is gonna equal square root of 7 over 4. Using my property, I can say this is the square root of 7 over square root of 4. What is the square root of 4? I cannot do anything with the 7, but I can do something with the 4 and make that a 2. Make that a 2. Okay? And class, when we square root it, it's imperative, it's important that we add the plus and the minus. Okay, we have to add the plus and the minus. And I'll show you guys why in a little bit. What is 2 squared? Or no, let's do what is 4 squared? Equal to 16. What is the square root of 16? Equal to 4. So you see how we started off with 4 and we got 4? Yeah. That means that the squared and the square root are inverse functions. Okay. The reason why we add 5 here, okay, if we started off with -5 and then we added 5, that's 0. If I go 0 minus 5, the opposite, right, the inverse function, plus and minus, right, we get here -5. So you started off with -5 and then you ended with -5. Yeah, those are what we call inverse function. The inverse function of a squared is the square root. Same thing. Okay. All right. And I'll show you guys why the plus and minus, why we add it here. Okay, because this is a good example of why. Okay, so we're gonna go ahead and get rid of the -8 by adding 8 to both sides. All right. So this would be 2x squared equals +8. And then I'm going to go ahead and divide by 2. So x squared equals 4, right? And then the inverse of squared is the square root. Okay. So x is going to equal positive or -2, right? The square root of 4 is 2. Why we do the plus and the minus is before we took the square root, my equation was x squared, x squared equals 4, correct? Why we have the plus and the minus is because x can equal +2 because +2 squared is 4 and -2 as well. What's the square root of, what's -2 squared? -2 times -2, which is +4. So can you guys see that they both equal 4? Yeah. So whenever we square root, that's why we need the plus and the minus, because the positive and the negative version works. Okay. All right. Cool. Okay. I want you guys to practice number 5. Okay, go ahead and then we'll talk about it in a little bit. If you do the math, right, you get up to this point here. X equals plus or minus square root of 11 over square root of 5, or you can put it as, or you had it as x equals big square root of 11 over 5. Right? Yeah. But again, we need to rationalize the denominator, meaning that there is no square root in my denominator. So if I have 11 over square root of 5 like that, I must multiply this by a value of 1, which will be square root of 5 over square root of 5. Okay, making this square root of 11 times 5 is 55 over square root of 5 times square root of 5 is just 5. And don't forget the plus and the minus. Okay, so that would be your answer. Okay, cool. All right. Okay. Now let's move on to this one. There's nothing around the square because this whole thing is squared. So my first move here would be to the square root. Okay, I need to get rid of that squared, right? So I have x plus 5 equals plus or minus square root of 6 is? Yes, it is 6. Yeah. And then I can go ahead and get rid of the 5 by subtracting 5 on both sides. Now I'm going to have x equals -5 plus or minus 6. Now, I'm not done yet, so don't freak out. Okay. -5 plus or minus 6. There's two answers embedded in here. In this one expression. That's -5 plus 6 and -5 minus 6. -5 plus 6 is 1 and -5 minus 6 is -11. So that's what my x value is. Okay. Cool. Yes.
Wait, why don't you distribute the square root to the 5 and the square root to the 5 and the x?
Because I don't want to. Because I can easily just get rid of it by square root. Yeah. You could multiply it out and then factor it. Technically you can. But why would you? You're just doing more math. I'm not a fan of more math. Right? Sufficient amount of math, please. Yeah. Okay. Next one. This one. Here, I'm going to get rid of this 3 first by dividing it by 3. If I divide everything by 3, right, this 3 cancels out with this 3, and I'm just left with x minus 5 quantity squared equals 18 divided by 3 is 6, right? And make sure that we do it on both sides. Okay, we divide by 3 on both sides. Now, it's pretty much the same thing as what we just did, right? Square root. So x minus 5 equals plus or minus square root of 6. Okay, and then I'm going to add 5 to both sides. Add 5 here, add 5 there. Now we'll be left with x is equal to 5 plus or minus square root of 6. Please get into the habit of putting the plus and minus in between, right in the middle of your expression. Okay? Do not write it as plus or minus square root of 6 plus 5. Okay, don't switch it up. Okay? Leave the plus or minus inside the middle. Okay, and that is your answer. Cool? Questions? No? Try this one. Right? Actually, let's just try this by ourselves together. Here. Yeah. Okay. No, you just lock eyes on each other. That's all. So square root, right? By taking the square root on both sides, that squared cancels out with the square root. So we have x minus 9 here. I don't need that anymore. Equals plus or minus 64. Square root of 64 is 8. Right? And then we're gonna add 9 to it to get rid of the 9. So x is gonna equal, you can just do the math here as well, if it's a clean number like 8, right? It would be 9 plus 8, which is 17. 9 minus 8, which would be 1. So your answers are 17 and 1. If that was confusing, then I would say that x is equal to 9 plus or minus 8. Yeah, and then if you go 9 plus 8, that equals 17. 9 minus 8, that would equal 1. Okay? Cool? Questions on this lesson? No? That is your lesson for today. Yeah? We solved equations via taking the square root.